Now let us discuss 56. Which is the correct thermal stability order for H2E? Here H2E means, here He means oxygen family. That means oxygen, sulfur, selenium, tellurium, and polonium. We know that there is a relation between thermal stability and bond dissociation energy. We know that bond dissociation energy, that means BDE, directly proportional to thermal stability. Bond dissociation energy increases, then thermal stability is also increases. There is a directly relation between bond dissociation energy and thermal stability. Let us try to understand what do you mean by bond dissociation energy. Bond dissociation energy means the energy required to break the bond is called an bond dissociation energy. When you observe in oxygen family from top to bottom, its size, elements size are increases. By increasing size, its bond length will also increases. By increasing of bond length, it is easy to break the bond. From top to bottom in oxygen family, we observe that by increasing of size, the bond length will also increases. It requires less energy to break the bond. Why? Because the size of elements increases from top to bottom. So by this concept, you can conclude that the bond dissociation energy order is H2O greater than H2S greater than H2E greater than H2 tellurium greater than H2 polonium. Why? Because in oxygen, its size is small when compared to sulfur. The small size, its attractions are very high. It requires a high bond energy than sulfur. From top to bottom, the bond dissociation energy decreases. Why? Because the size of element decreases. It requires less energy to break the bond. Okay, we know that bond dissociation energy is directly proportional to thermal stability. Then you write the thermal stability order H2O greater than H2S greater than H2SE greater than H2 tellurium greater than H2 polonium. 3 is our correct answer according to the given question thermal stability order.